Hello everyone, welcome to our DataHour session. Those for who are new to this session, let me give you a brief introduction. DataHour session is a 1 hour dedicated session where you learn about the data science and its related topics and technologies. So for this session, our topic is intelligent knowledge mining with Azure
Cognitive Search
and Graph database. So for our session, today's our speaker is Priyanka Shah, and she'll be taking up the topic. She is currently working as a group manager in Avanade and with an experience of 10 plus years in analysis. Hope I didn't mispronounce it. In design and development and client server, web-based and TAD applications. She is an influential speaker at Microsoft and other technical events for Microsoft Technology and Stack and ML.NET, conversational AI bot framework, Azure Cognitive services like speech to text, face recognition, and custom visions. So Priyanka, I'll give the stage over to you and you can take over.
All right. Hi guys, hope you can see me. And just let me know if my screen sharing is okay. Are you able to see my screen? All right, so okay, so let's start. So hey everybody, good evening, thanks for joining, and let us walk through an interesting topic here, which is intelligent enterprise content mining, okay, with the help of Azure Cognitive Search and knowledge graphs. All right, so this is the agenda today. We will look at why there is a need for enterprise-based content intelligence, content mining. We will see what is knowledge mining. We will look at various demos. We will see how typically a knowledge mining architecture is implemented and how graph databases and intelligent indexing, document indexing comes into play here. And feel free to put up your question answers anytime you want to. All right. Okay, so just trying to see. Okay, I'm just trying to see how to sort of minimize this screen. Okay, but let's continue, right? So sorry, yeah. So, like today we have a lot of knowledge around us, right? So, I mean, not knowledge, we have a lot of data around us, right? So data in the form of your social media, data in the form of your social media interactions, data in the form of, your enterprise related stuff, data in the form of your video, audio, interactions on your web pages, right? So that is just data, right? Unless we mine that data, we harness that data and convert it into some insights, the data is not really useful. So there's a lot of data lying around. There's a lot of data which has been, so if you typically visit websites everywhere, you have this accept cookie sort of thing, right? And then you have to accept all cookies, which is trying to actually create a digital footprint, and all of our activities are tracked. So, I mean, have you given a thought why all this is tracked and how it helps typically media houses and social media websites to build a profile for you and, personalize the feed for you, right? So all of this data which is collected, how do we harness that data, right? And not only data which is available publicly, but data within your organization. So here's a very realistic use case, right? So let's say, like, you wanted to check in your organization that what was certain onboarding process, correct? So probably, what is the way to reclaim back your employer provident fund once you resign from a company. And then you might be directed to some person, to the HR, then HR department will guide you to the claims department. The claims department might guide you to some other department. There's a lot of paperwork to be done. So which is why organizations in probably a decade ago or so had concept of, content management. So there's a lot of different content which is siloed in different departments, right? So they wanted to bring that the content into a central marketplace sort of a thing, right? So central location where everyone can search, and then content would be made available to everyone. Okay, so far so good. So then there were content management systems where their SharePoint came in, right? Then after content management, there came a problem of your tracking the versions of that particular document, like upgraded version, modified version sort of thing. So that's why we had a lot of good systems there for knowledge management kind of systems, right? But now the problem is we are above that. So we are just above searching information via just, pure keywords, key phrases. So now we are in an era, or we are in probably a sort of, modern situation where users are expecting a lot from systems, right? So we are not just happy with searching pure keywords, key phrases, and happy with the hit in the search result. So let's say I'm searching for electric cars, and then, there are documents in my enterprise talking about electric cars or electric related stuff, the keywords electric and cars, and they give me those documents as my search results. I'm no longer happy with that. I want to know more. I want to know that, if electric and car, that particular word was not present in my document, but probably it was like, energy friendly cars, right? Or renewable energy cars sort of thing, or green cars, environment friendly cars. So I also want to dig out search results which are semantically similar in meaning, not only just pure keyword, key phrase based searches, right? Again, I also want to be reminded of recommended documents. So, people who search this also search this. What you typically find in your Amazon, eBay sort of settings, right? Where you're purchasing a product, and then you're immediately recommended that people who purchase this also purchase this, correct? So this sort of a thing, if you want to do, where it has word semantics, where it has search based on semantic similarity, contextual similarity between different documents, between the question which you ask. And now we have gone over and above that, and I want my system to be able to understand the question which I'm asking, and if the answer is hidden somewhere in the documents which I have fed to my system, it expects me to give that answer back from the document verbatim, without me having to actually open the search results and see which document actually is the most fit to my query. All right. So which is why we are in the middle of a paradigm shift from just a search driven sort of a system to an intelligent enterprise. Okay. What I mean by intelligent is all these things. I no more want just keyword, key phrase driven searches. I want semantic searches. I want recommendations. I want personalized searches. Okay. So next time I hit a website, last time what I searched, and probably, what I like to search, those sort of the search results should be oriented based on my personality, my choices, okay, my user profile. I also want to have feedback based learning, which means in the sense that, if a particular search result was consistently downvoted a lot of times, next time around, the search results should be re-ranked, right? So this sort of a feedback based mechanism is also necessary, right? So this is what we term as a paradigm shift. So users are typically expecting a lot from your end systems, and that is how AI and knowledge graphs and machine learning, data science all coming in together to give us this holistic, intelligent enterprise experience. All right. So this is, typically some of the statistics like data explosion, right? So what is data explosion? Meaning, just let me move this guy a bit. Okay. All right. So data explosion, meaning, we are typically spending more time searching, right? Or even in an organization, if I want to particularly search for some term which is related to some document. So imagine in an oil and natural gas setting, right? I want to probably search for a particular equipment, a part number, or probably, some oil field location, the drilling conditions of an oil field, geological conditions and stuff like that. So if we were to go with the previous keyword key phrase based search, then a lot of time I have to just guess that okay, the search term which I'm typing may not make a lot of sense while searching the documents, right? So I have to keep on guessing the correct search term and then trying to do a trial and error on the search result to get the most relevant search result. Correct. So because of the amount of data now which we typically have, I cannot really afford to lose so much time in doing this hit and trial method where I'm just punching in keywords and trying to see which is the result closest to my search, right? And I think all of us have been in the scenario when you're trying to search in Google some technical error which you've got, and then you're probably modifying a word or two here to sort of get more search results or to get more relevant search results. You will try to put some a particular word into inverted commas as well, so that that term is probably zeroed down or given more importance in your search. So these kind of things, but we can't really afford that in current scenario where the data explosion is exponential, and then we typically don't have a lot of time to waste doing this sort of hit and miss search, right? So what are the current enterprise challenges with data? So how do I empower my workers to be a part of my intelligent enterprise? So one thing is to build an intelligent enterprise, but then another thing is to actually empower my people to sort of get used to it, to derive the most potential out of it, and to proliferate its usage across the organization, right? So then I want to have improved collaboration between workers. As I said, I want to have a personalized content and search, right? Want to have a consolidation of all the content platforms, because in an organization enterprise, your data will be scattered. Like you will have videos, audios, you will have images, you will have unstructured data, you will have structured data. So bringing all that data into one platform, linking that data and making it searchable, right? And then of course having a beautiful UI to go with it, intuitive as well, right? The UI cannot be cryptic, it has to be simple and easy to use, intuitive, and of course empower your users to use it, okay? Make it a part of their daily routine. All right. So which is where knowledge finder comes into picture. So knowledge finder is, you take the data which you have, you organize it, you make it searchable, and then you extract knowledge out of it, you extract insights out of it. So that is not just dumb searching, but the data which you the results which you find, right, they will give you actually some sort of insights, some sort of knowledge, which is why we call it as enterprise knowledge mining, intelligent knowledge mining, right? So what does a typical knowledge finder look like, right? So it has AI assisted search, right? It has summarization and preview. So I'll show you what a summarization and preview mean, right? Okay. So summarization and preview, typically without, diving into the demo, what it means is like, probably when I search, let's go back to our, experience, our search term of electric cars. So when I'm searching, let's say, electric cars, or let's say lithium batteries. Okay. So lithium battery, then probably it will give me a search results of documents which has that term lithium battery or something semantically similar to lithium battery, let's say ionic batteries. Now I don't have the time and the patience to actually go through each and every search result link, open it, look at the document content and see, if it is relevant to me, or is this what I'm looking for. So which in turn gives us the summarization and preview feature, meaning the AI on its own, like on the go, dynamically summarizes the document content on the fly and then gives you a summarized view of the content, right? So even without opening the document, going into the text content, I can immediately have a preview, a summary of what is there, and then move on if it doesn't match my search query. All right. And again, so not only just AI assisted search and summarization, feedback and analytics. Most of the time, you have these option of downvoting certain things on, if you see on certain Microsoft websites, MSD and MS Learn. So if you're searching for something and then, some search page pops up and then they ask you that, did it solve your question, or did you find what we're looking for? And you can either upvote it, downvote it, or have a star based rating system, right? 2-star, 3-star. So this is called human in loop, right? So you also typically systems have a human in loop, which will improve the cognition of the AI. And then, in the long run, after it has garnered sufficient feedback, it will be able to re-rank the result, okay, and give you better relevant results. Not only that, not only text search, it can also do video and image search, okay. It can also personalize the search. So personalize the widgets, personalize the UI based on your searches, recommend you stuff, articles or images or videos based on what you've viewed in previously, or content which is related to your searches. All right. So this is also what typically our social media websites do. So what you see on your YouTube videos, your Instagram feed or your Facebook feed, do you think that it is by a stroke of luck that you are seeing what you want to see? No, right? I mean, as soon as on Instagram you interact with some video, some feed, probably it could be, let's say, I interact a lot with the art and craft videos for my little one. So immediately the next time I log into Instagram, I'm being shown similar videos, right? So how does it do that? It depends on what sort of interaction you have with that particular feed. If it is a positive interaction, then because you clicked on that link, you opened it, right? You generated some sort of an interest by clicking on that link, and which is recorded as a positive reinforcement, and that is awarded like as a this is a reward given to the algorithm, and then that is how it builds my profile of my likes and dislikes and personalizes the content. So this is also what intelligent enterprise content search would do. It would organize the search results based on my user profile, based on semantically similar search results and stuff like that. All right. We will also explore the AI assisted search a bit. Okay, so typically what happens is, imagine you have this whole corpus of unstructured data lying everywhere. Okay, it is in the form of images, it is in the form of audio, it is in the form of video, it is in the form of structured data, relational databases, unstructured data, PDF files, document files, Excel, CSVs, and think of all of the unstructured data you can think of, right? So you need to extract the content from all of that. So imagine a PDF. From a PDF, you need to actually do optical character recognition. So there are services available in the Azure AI service, cognitive services suite, which will enable you to extract the content out of the PDF. So typically something like Azure Form Recognizer, right? Which will enable you to extract your PDF content, make sense of it, right? So whether it's a table, whether it is a dictionary key value pair of certain predefined things, like for example invoices, supplier name, dates, various date fields and stuff like that. So you extract that content, right? You index it meaning. So there's an interesting concept here, right? How do you make a document searchable? So take a normal Word doc, right? So take a normal Word doc. How do you make it searchable? Searchable meaning, like, let's say you have 5 to 7 Word documents, probably just a page each, and I want to search a word, probably summary from those 7 documents, right? So for a human, it is like, how do you do is like, probably you will open each of the document, you will do Control F and you will search, is there any word called as summary or summarization, and your word search will probably match the word partially or fully, okay, and then show you the relevant matches. All right, how does it work in a AI system? So an AI won't really open your documents and search the term, right? Search the word, right? So there is something called as indexing. Okay, so indexing meaning it will take the content from the document, the text content from the document, ingest it into an inverted index engine. Okay, so something like a Lucene index. So it will ingest that content itself into a sort of elastic engine. Okay, it's not a database. We'll call it as probably a mechanism to make your content searchable. So it will index into an elastic engine, and then from there you can search the content. So it will give you a lot of natural language processing things like partial search terms. Okay, or your root searches. So for example, if I'm searching for playing, then it will match played, play. Okay, and so on and so forth. Or if I'm searching for something like gone, okay, so it will also go, went. These things also it will match. So based on the NLP root, stemming, lemmatization concepts, right? So these are all the advanced NLP concepts. We will surely not dive deep into those, but yeah, just to put things into perspective, right? Just to put to drive the point home, that this is how AI makes the content searchable by indexing it into a engine, and from there you can search it, right? So this is where it comes, these concepts comes. AI assisted search: you are ingesting the content, you are enriching it, and you are exploring it. Okay, so let me give you, come on, let me give you some interesting examples of how text analytics works, right? So let us look at some of the interesting, concepts of what is enriching a data, what is, exploring the data, and what are keywords and key phrases before we move on to some of the advanced concepts and we look at some interesting demos. All right. Okay. So let me quickly walk you through what are some of the text analytic facilities which are afforded to us by modern cloud systems. All right. Okay. So let us check something which is, I'm so sorry, it closes off. So let us do, yeah, let us look at the Cognitive Language Studio. Okay, let me sign in. And we will look at some of the interesting language text analytics functionalities. Okay, advanced NLP. So from that you will come to know a bit about what are keywords, key phrases, and so on and so forth. Okay, I need to sign in with my account. Just give me a second. Okay. Okay, while it is opening, or it is opened. So, Language Studio is something where, you can look at the language offerings, which are, so NLP is one of the backbones of making your enterprise search engine, right? Okay, so let us look at, some of the NLP facilities. Okay, so what is extract key phrases, right? So I'm going to show you how AI actually extracts meaningful, keywords and key phrases from your text without even being trained to do so. Okay, so these are out of the box NLP stuff available. Okay, so let us, for example, look at one of the sentence here. So I'm taking some of the existing content here, right? So which is saying Mateo Gomez, a 28-year-old man, suffered a car accident driving near his home on Hollywood Boulevard, on so on and so forth, and was admitted to some hospital in Los Angeles. The patient showed signs of chest trauma indicating possible rib fracture, and so on and so forth. Okay, so this is some of the sentence which is detailing about some accident which took place and some of the medical reports of that patient. Okay, so what were the procedures performed, and patient was in ICU, and the patient was discharged under the supervision of his caretaker. Now, what I'm going to do is I am going to run a service to extract keywords and key phrases. All right, so I'm just going to run this, and then as you will see, it is able to directly, without me writing a single piece of code, the AI, the NLP inbuilt out of the box in Azure Language Studio is able to extract certain meaningful keywords and key phrases from the document itself. All right. So for example, in this above paragraph, as a human user, right, without AI, as a human user, what my brain immediately registers is the name of the person, his age, his the date on which he suffered accident, and so on and so forth. Correct. So you look at the AI generated keywords, key phrases, it is almost doing the same thing. It has registered Mateo Gomez. Okay. It has registered that he's a 28-year-old man. Then it has given that he was in a car accident. It has identified that as a key phrase, and Hollywood, and so on and so forth. Okay. Why keywords and key phrases are important? Keywords and key phrases become important because they will enable you to organize your content together. Okay. So probably if I have a lot of keywords and key phrases in a document talking about all these medical things, right? Like there was a chest x-ray taken, accident related stuff. So keywords, key phrases enable content organization by organizing or classifying similar content or related content together. All right. Okay. So this is also one of the important aspects when I'm searching a document or searching a text corpus. All right. Okay. Another important concept when I'm searching text corpus is entities. Now, what are entities? Okay. So entities meaning, like for example, from a text, let us see an example. So from a text here, let me let us take probably some simple text. uh, this is complex. Okay, anyways, so these are named entities. Okay, let us do that. Okay, let us take the same example which we had, a person suffering an accident. All right, now let me run the named entities thing, and from this text, out of the box meaning using the inbuilt AI from the Azure AI services, what is being extracted is person. Okay, so it has identified that Mateo Gomez. What Mateo Gomez is a person, age is a quantity, then car accident is an event. Okay, this particular thing, Hollywood Boulevard, is an address. This one, August 17, is a date. Then some hospital name is an organization. This one, Los Angeles, is a location. Date and time, person type. So these are entities. All right, these are entities which has been defined by the NLP of Azure. You can have your own entities defined. For example, if I am indexing, or if I am making open source music demo in which I'm making music file searchable, then I can have my own entities like artist, for example, the music genre, which is rock or pop or metallic rock, and so on and so forth, and the albums of the artist. So these will be my entities. So next time when I'm training my own AI algorithm for a music data set, which is one of the demos we will see shortly for content mining, content search and recognition. So let's say, if I'm searching for, let's say, Van Halen, then Van Halen, it will recognize as an artist. Okay, Van Halen recognized as an artist. The Beatles, it will recognize as a band. Okay, then metallic rock, or pop rock, or sorry, metallic rock or hard rock, it will identify as an entity which is genre, music genre. Okay, so this is also the way in which it will extract and enable you to group your search results together. So you remember, like on your search pages, you have the left hand side menu. So let's say you go on your hotel booking websites or your flight booking websites, right? So on the left hand side, you have faceted search. Faceted search meaning, let's say I'm searching for some holiday resorts in Philippines. All right, and then on the left hand side, I'll get an option of 4-star, 5-star, and within 4-star, 5-star resorts, I will have garden facing, swimming pool with all the gym facilities, 1 room, 2 room, residential suite, executive suite, villa, so on and so forth, right? So this left hand side which you see are the entities. This is how your results are organized. All right. Okay, so a lot of powerful stuff which is afforded by some of the text analytics. Another interesting thing I wanted to show you was dynamic summarization. Okay, so yeah, summarize documents. All right. Okay, so summarize documents is, as I said, right, on the fly, it will generate a summary of the document. Okay, so let us look into this document. So as you can see, it's a huge, humongous text, right? And as a person who's typically busy, we don't have a lot of time to, look into all the details and capture the most important things, essence of the text, which is where the summarization service comes in handy. So I just run, and when I'm running this, I will get a quick, bird's eye view of what my text is trying to convey in probably 3 to 4 sentences, right? So that this executive summary is given, and then this original text is given, and what sentence makes the most relevance and sort of, gives me a context of that entire paragraph is earmarked, and that is given to me as the summary. So as you can see, most of that, from all of the text, there are 3 to 4 sentences which are given to me that will help me put this content into perspective. All right. So this is one of the features of dynamic summarization, how AI summarizes, so comprehends your text and then gives you result back. All right. Okay. So with this, few features being shared, let us move back to our content search. Okay, so when I'm talking of ingest, enrich, and explore is what I just showed you. So I'm ingesting the content from the document. I'm enriching it, meaning I am extracting keywords, key phrases, entities, relationships from those documents. Okay, and then I am making it available for searching, exploring. Okay, and how we do that is by using natural language processing flows, and then by using some of the AI algorithms out there based on GPT-3, BERT, and stuff. Okay, so what typically happens, like when you have this sort of an intelligent knowledge finder in your enterprise, what happens, right? So it helps you achieve 15% increase in the employee experience. So quick searches, semantic searches, right? And again, a very reduced result set. Like when I'm searching something, it typically doesn't give me hundreds of results. So imagine this sort of a very powerful search engine, how it would serve our talent sourcers, so talent acquisition teams across various enterprises. If they could just put in few keywords, and then the absolute perfect fit candidate resumes would pop out, and they don't have to sift through a barrage of applications, then that would make their life so simple, right? So this is the upcoming areas in which content finder is being implemented to give the user a seamless and intelligent experience, right? So of course, if you get a very relevant result set, then you would lose less time in sifting through the results and further refining them. And then you are sure that, whatever is popped out in the first top 10 are actually the good candidates in case of a resume search sort of a engine, right? Okay, so let us look at a few of the demos, and then we'll come back to a bit of technical details. I don't want to bombard you with a lot of intricate technicalities with advanced NLP and stuff. So let us look at some of the fun parts before we go into the last two technically boring slides into the nitty-gritties of how actually the system works. So let's do the fun part first, and then probably we keep a bit of the somber stuff at the last. Okay, so I'm going to show you a demo of music, as I said, right? So this is a demo which we have made for searching music, right? And then let me go to semantic question and answer. Let me show you the difference between what is just search and what is semantic search. Okay, so let's say I want to let me just tell you that what we've done is we have ingested around 2000 Wikipedia music documents here, open source music documents, which are talking about various artists, their albums, collaborations, bands, and stuff like that. And from all these 2000 odd documents which we have extracted from Wikipedia, we have defined our own entities. Like we have defined 3 entities. One is artist, one is genre, one is an album. And then we have put these documents into Azure Cognitive search engine for searching all this. And now imagine that I have 2000 odd documents talking about possibly many artists and music and their albums, and now I want to search something. So these are all popular artists and music, right? So known names, not something like which is obscure or unknown. So let me search. So for example, who are the members of the Beatles? Okay, right? So now when I'm asking a question like this to probably, Google, right? So what will Google give you? It will give you a list of, search results directly, like document links. And if there is an answer somewhere which is available, it will give it to you. Much the same way, the search algorithm, the Azure Cognitive Search with its AI engine, what it is doing is it is going through all those 2000 odd documents which we have put in the search engine. And if there is an answer to the question which we have posed here, it will give that answer back to us directly without me having to go into a list of search results. And then it will give me the confidence with which, I can trust the search it has given. Okay, so I don't know, like, this answer was taken from which of the 2000 odd documents, and as a human probably I would have to go and look into each of those documents. But see, with the AI it is so simple that, and this is called a semantic search. Semantic search meaning whatever you are searching the question, if it has a direct answer in the text which is in your search engine, it will give you that search engine. Okay, and it will give you the score. Compare that with your typical search. So let me just go to normal search, and normal search, oh, come on. Normal search, when you do, I clicked on the wrong link. So normal search, when you do here, let us go back to the search. So normal search, when I'm doing, it will give me search results. So let's say, for example, I'm searching for Van Halen. Okay. And when I'm searching for Van Halen, it will give me all documents which has Van Halen listed in it, right? So as you can see, Van Halen, all the exact keyword, key term match, right? Okay, so you can see Van Halen, and these are the entities. Okay, so as I said, right, I had 3 entities defined: artist, album, and genre. So I'm searching for Van Halen. Van Halen, I can see that there are so many genres available for me to refine my search. So I want to say Van Halen in grunge. I can click on these, left-hand side filters. Okay. I can also click on artist. Artist meaning all the documents which I have, search results which I have given here. What are the other artists listed apart from Van Halen, right? So for example, Alice Cooper, Jimi Hendrix. Okay. And if you look at album, then it will be all the, albums which are related to the search results, which will show me Van Halen. And as you can see, you have, probably, you can have more than one page of results, and then there will be paging available here. Another interesting thing to note here is that there is entity map. Now, what does entity map do? Entity map will enable me to understand the graph relationships between my search results. All right. So let me here, for example, limit my search result only to artists. Okay. Artists meaning what are the artists that Van Halen had collaborated with. All right. So you can see here now from graph relationships, I will be able to see all the first order, second order, and tertiary relationships. I can control the levels here. Okay. So let me put the level at only 1. So which means, artists who were directly in a collaboration with Van Halen on one of his albums, right? So for example, Van Halen and Elvis Presley, Van Halen and Led Zeppelin. So the direct relationship tells me that they were very closely related and, probably collaborated in some way or the other in some type of music or the other. If I drill down further, like I want to check now what are the tertiary relationships, which means if you can see Van Halen, Elvis Presley, John Lennon. So there was, at some point of time, John Lennon had also collaborated with Elvis Presley on probably something different. Okay. But I'm able to also see the tertiary relationships, right? So for example, even here, you can see Van Halen and then, David Bowie and probably fire and something like that. Okay, right? Then I can increase the complexity max level 3, and then I will be able to see the tertiary relationships, so on and so forth. So that will help me understand, how my results are connected. And that is where graph learning comes into picture. So graph search. Okay, so nowadays, apart from just your normal typical enterprise searches, graph searches are the next big thing, right? So graph searches, it will enable me to search and derive meaning out of my search results. So probably I will be only interested in search results which are directly talking about Van Halen's immediate relationships with certain artists or genres or albums. Okay, so now I'll probably move on to genre. I can select the facets for the graph search here, right? So now I'm saying that I want to see all the facets. I want to see all the genres in which Van Halen was directly related. So okay, I just came to Queen. Let us go back to Van Halen. And yeah, okay, so now I want to search what are the type of music which is directly associated to Van Halen, and I'll be able to see immediately from my 2000 odd documents what are the type of genres which Van Halen was immediately associated with, right? So progressive rock, emo, Christian rock, country music, hard rock, blue rock. So that enables me to understand more about my own data, these sort of graph relationships. So the things which you are seeing here in circles are called nodes, which are entities, and then these things are called as relationships. Okay, so something like Van Halen performs in a genre. Okay, Van Halen belongs to a particular album or is a part of an album. Okay, so these are relationships and these are nodes, and this is how graph databases also work in tandem with your typical knowledge search to enable you to be able to make sense of your search results. Okay, so we talked about semantic question answer, we talked about graph. So what about something which I had asked you at the very first, right? So if I'm searching for electric cars, but my documents don't have electric cars, okay, so probably just to put it into perspective what I'm telling you, let us go back to your search results. All right, and let us try and search. I'm just saying, okay, let us try and search I don't know, maybe some term like okay, metro project. Just throwing something out of the blue here, right? And then if there is no document with this particular full phrase metro project, so it is matching certain keywords metro and all. But then if I wanted to actually see the metro project sort of a thing, I don't have anything in my search results because I'm actually looking only for perfect matches, perfect keywords, key phrases. All right, but what if I wanted to have synonym search? Like I said, electric cars, but there is no electric car mentioned anywhere in my document. But there is something called as, for example, or probably I'm searching for robotic cars. And there is no word called as robotic cars in all my text documents. So there is no keyword hit. But there is a synonym. It might say driverless cars. Okay, it might say your smart cars. Okay, something like that. Those are still robotic cars, right? Or it could even link me to documents which are talking about Tesla or Grab, because they are the ones who are revolutionizing the driverless car space, right? Smart cars and driverless cars, robotic cars. So what about synonym searches? All right, so as I said, right, not only keywords, key phrases, but also semantic word searches, synonym searches is something which is also big thing for intelligent uh, enterprise searches. Okay, so let me show you something else here. So let me tell you about, if I'm searching for railway projects in Australia. Okay, so now my documents don't have Australia mentioned anywhere. So this is, probably a search based on one of another mock data for one of a client of ours, and I'm searching for some railway based projects which they have carried out in Australia. Now I'm searching and just look at how smart these content search engines are. So railway projects in Australia, and it has searched So there is nothing called as railway directly, keyword mentioned in any of the documents. But railway is synonymous to metro, right? Metro or subway or MRT. In Singapore, we call it as mass rapid transport, MRT. In some places, you call it metro. In some places, you call it a subway, right? So then it is able to understand this sort of a word linkage, synonym search or word proximity search. So railway and metro. Then Australia, it is also, synonymous to all of the Australian cities like, Sydney or Gold Coast or Melbourne or Brisbane or Queensland. It is able to understand that when I'm saying rail projects in Australia, I'm actually, trying to search for metro projects which are based in and around Australia. And then it is able to search these kind of projects for me. All right. And then I can always, rate my search. So here I'm giving it a 5-star because yes, that's what I was looking for. And I can slice and dice the search and refine the search further. So now I can search for, for example, project value, say project value more than 10 million, time frame is something less than last 7-8 years. And it will progressively, refine my search result and highlight those aspects as well. And this is what I call as feedback based learning. So you can rate the search result. Okay. So as soon as, over a period of time, as more and more users rate this search result for this type of a search query higher up or with more stars, the engine learns, right? The engine learns to re-rank and show this result higher up. Consequently, if I'm consistently rating it lower, next time around when I search for railway projects in Australia, this won't be the the document which will be shown to me higher up in my search results, but probably, down, lower down in the search results. All right. Okay. And let's talk also of keywords, key phrases, right? So when I'm searching for keywords, meaning from all my text corpus, as you can see, it has extracted keywords and which are salient features of my text. Okay. So for example, spatial design, CCTV, project location, 270-meter cable stayed bridge. Okay. Right. Even going back to the music demo, if you click on one of the search results, you will be able to see the metadata, and on the left hand side you will be able to see the keywords, key phrases extracted, and you can search those keywords, key phrases within your text, right? So here, indie rock, post punk, right? Okay. So yeah, and then you can have a lot of interesting stuff done here. Like you can download the document and you can, have maps. Like for example, if there are entity relationships mapping your content, like for example, mapping your content as something like, for example, this is punk rock is a sort of entity, or someone is playing punk rock, that sort of a map view it will show to you in case you have that functionality enabled. Okay. All right. So a lot of, access control based mechanisms, lot of searching, advanced searching, semantic search, lot of interesting stuff possible with intelligent content search and graphs. Okay. And increasingly, semantic search and graph relations and graph searches are being taking the forefront, are in the forefront for the entire content mining, knowledge mining space right now. Okay. So they both go hand in hand, like graph machine learning or graph based searches, knowledge graphs, and your index like document search engines go hand in hand. Neither can survive without each other, because one gives you the text search, like full text search, and other gives you a narrowed down relationship between your documents, between your between the knowledge that you have ingested. All right. Okay. So another cool demo which I wanted to show was for, again, if you go to the language studio itself, I go back to my language studio, I wanted to show you custom named entity recognition. Okay. So here, like the previous music demo, I have indexed documents which are movie plots. All right. Okay. So which are movie plots here. So for example, I just showed you the music demo and I told you, like, for example, how does it know that Britpop is a genre? Okay. Or that it knows that, someone like Led Zeppelin or Alice Cooper is an artist, or something else is an album. How does the search engine know this, or how does the AI know this? So this is how we do it. So this is something called as, how you define your entities. So whatever text you have, you need to annotate it. Okay, so we have a lot of data annotation tools. So what I have done here is I have this text. Okay, so these are movie plots which are taken again from Wikipedia, all open source data. There is nothing confidential here, right? So, and from that, I'm going to, so in a movie plot, what are the possible entities, right? I will have a protagonist, the central character, an antagonist, okay, who is like the villain. I will have some supporting actor. I will have a movie setting. I will have the type of movie. It is like it is a drama, comedy, tragedy, thriller, okay, horror. And then I'll have the period meaning, the year in which that movie was set and stuff like that, like the Renaissance period, or it was the World War period, or it was, the millennium period, and so on and so forth, right? So I can, as you can see here, I can add entities here. So I'm, let's say, adding an entity, and I am adding an entity, say probably movie, I don't know, yeah, director, probably, who is the director of the movie. All right, something like that. Okay, and now if I'm adding this entity, I can tag the text here and indicate what entity it is. Okay, so for example, Danny O'Neill is madly in love with this teacher, so on and so forth. So I can actually tag Danny O'Neill and say what type of entity it is. So I've tagged it as protagonist. I have tagged the other character also as protagonist. I have tagged someone else as antagonist, and so on and so forth, right? So you can tag here something like 30-year-old man, and you can indicate that is the age of the villain, and so on and so forth. Okay, and I can so I can go on to another uh, file and show you. So Aduri Aduri Aman finds herself the target of federal agents, though she's self-helped. So okay, so I am going to tag this person and say she's a protagonist. Okay, and the stranger, so I'm going to tag this as the antagonist. Okay, this include United States war on terror, tsunami, blah blah blah. Okay, so yeah, and then I can various contemporary events, meaning this is in the millennial period. Okay, so in the 2000s and stuff. So I can I can put this tag here, and then I will say it is a period. Okay, this is the period of the movie setting, correct? And then this is how I tag text, and then I am able to train. Okay, so I click on training, and then it will, whatever text I have tagged, it will train on that, and automatically it is trained now to predict or to infer the entities in unseen text. So this is how we are actually getting entities and recognized from the text. So that is how, by tagging an annotation, now my AI knows that Britpop is a type of genre, or Led Zeppelin and Bob Dylan are artists, and it makes the searches easier. So these entities are then populated into the knowledge graph as well, right? So these are the entities which you see here. The knowledge graph is actually showing you nothing but the entities. So the entities which we are tagging here, Aduri Aman and Saif and so on and so forth, are the things which end up getting showcased to you in your knowledge graph. Okay, so coming back to our content search. So how it works in the background. So background, I told you, right? We are ingesting documents from a variety of sources. We are enriching it meaning we are extracting these entities, we are tagging the data, we are extracting keywords, key phrases, we are enabling dynamic summarization, and finally we are exploring it. Okay, so exploring it meaning how we have searched it on all of the demos which we have seen now. Okay, so this is a typical technical architecture, how it will look like, right? So these are the different data sources: video, media, document, PPT, PDF, content databases, that you are going to pull it into Azure, and then you are applying cognitive skills. Okay, so NLP, which is entity extraction, OCR, image recognition, and then you will be indexing into the cognitive search, and from there you will have a web interface or a chatbot interface to be able to mine the knowledge which you have harnessed from your data. So this is data. Here it is converted into knowledge, okay, with the help of all these background infrastructure, AI algorithms and stuff. And then this is how the knowledge itself becomes searchable. So this is your data. converted by some processing into knowledge, and this is mining the knowledge onto the UI. All right. Okay. So what are the use cases for knowledge finder? Okay. So knowledge mining. So you have infographing, correct? So visualization of contextualized information like we saw in the graph databases, bundle content, so that grouping your content together, similar documents or similar categories together, solving NLP questions and answers. Okay. So for example, if I'm trying to, like I showed you, right? I'm posing a question and it is able to find the answer in that entire text corpus. Collaboration, meaning, people, like-minded people tagging together. Another interesting thing for NLP, right? You see on Stack Overflow, whenever we are asking questions, there are, answer tags related to that question. Or forget your Stack Overflow, that is like a very technical example. Your Instagram post, right? Your Instagram post, your Facebook feeds and all, you have a lot of hashtags, Twitter feeds, right? So your popular Instagrammers and bloggers, they always associate their post with hashtags like hashtag YOLO or hashtag women in AI and so on and so forth. So normally when I tweet my technical posts, I use MVP because I'm a Microsoft MVP for AI. So I use a lot of MVP related, Microsoft Azure AI related hashtags, right? So what does this hashtag do? The hashtags are trying to identify. So there are, people who are not people, there are accounts are watching that hashtags and, screening content which is tagged with similar hashtags, right? So this is how a tweet goes viral. Tweet goes viral, meaning, probably it is trending a lot, and then some of the hashtags get attraction, and then, it is further trended and so on and so forth, right? So social collaboration, meaning with all of these tagging of your data and semantic similarity searches and all, your collaboration increases. All right. And then best possible information within a blink of an eye, right? So as you can see, I just typed a question and it was able to search a plethora of text documents. Next best action, like what you have on your content websites, right? On your marketplaces, right? People who bought this also bought this. Auto crawling, which is, getting similar information. So if I train my algorithm to probably get me weather information, similarly I can also train it for getting the sports scores, live sports scores, right? And then people centric, meaning I can also find the best people related to a topic. So let's say in my enterprise I'm searching for the best, software engineers for a particular project. Then getting and extracting out the correct people for the correct match for that particular search term is also something which, possible with the help of knowledge finding, okay, knowledge mining. And then these are the solution components, like we are using AI based services, form recognizer, Azure functions, cognitive skills, and enriched synonyms, like for example, as you saw, right, metro and rail and subway and Australia and all the Australian cities together. So recognizing synonyms, doing semantic word searches, these kind of things. Or green energy is equivalent to renewable energy, robotic cars is equivalent to driverless cars, these kind of word semantics, cosine word similarity, vector searches. So much more is possible. And this is just the tip of the iceberg, right? Whatever I defined to you, we are going beyond that. So beyond even, just searching your static text. Now we can also search videos. Okay, we can tag videos, we can identify speakers in the videos. You can do an image search. So if I'm searching for, let's say, Van Halen with a guitar in my music demo, it will show me documents which are having Van Halen with the guitar. So I'm not saying that we have implemented it in my demo here, but just to put things into context for what knowledge mining and all of these AI systems are able to achieve. So this is one of the things, like it will be able to also do the image searches, like how you are typically doing your Google image search, right? You are searching for show me a daffodil, how does a daffodil look like, and then in the images you get an image of a daffodil. Similarly, if I'm checking here for Taylor Swift with the guitar, then it will give me documents which actually have the image of Taylor Swift playing a guitar. right? And which is, I mean, the power of modern day AI systems, algorithms, and cognitive search engines, and also the power of advanced language analytics with the help of OpenAI API, GPT-3, BERT, right? So a lot of humongous interesting possibilities available for us to explore today. And yeah, so with that, I come to the end of my sessions. I'll be happy to take any questions.
Before we proceed to answer your question, I would like to request each one of you to please fill the feedback form. It really helps us a lot. I'm launching that. Then Priyanka will answer all the question. It's in a Q&A section.
I see a lot of interesting questions here. So let me know, analytics, Vidya, let me know when I'm okay to answer the questions, because I see a lot of nice questions.
Yes, you can answer.
All right, okay. Okay, so I see a question from Somen Dupal, similar to transformer attention based model. Absolutely. So if you see, right, transformer attention based model, these are all what your BERT and GPT-3 and all implement anyways. So absolutely, like, attention to detail. What is transformer attention? It is attention to detail in an image, in a text, and exactly these are the building blocks of your NLP, correct? So these are one of the models, I will say, which are used in your enterprise systems, but there are a lot more, right? Because as I said, the search engine is capable of searching images, videos, and a lot of other content. Okay, so yeah, one of the aspects is transformer attention based model. You're absolutely on spot. I see a question from Madhu. Can these past keywords transfer to a table spreadsheet? I mean, can it be classified properly? Absolutely. Is it a paid service? Depends, right? So if you, in Azure, if you're using this, see, if you're using out of the box service for keywords, key phrases, you need to have an Azure subscription, right? So I have an enterprise subscription, so I don't have to pay out of my pocket. I have my own MVP subscription. So yes, these AI as a service which are given to you by cloud platforms are paid services, but otherwise there's nothing stopping you from building your own, so there are a lot of libraries, Python libraries out there which are free of cost and which enable you to do these keyword key phrase extraction. Okay, just that, why to reinvent the wheel, right? Why to write a wordy Python program to do the same simple NLP thing which is available with a few bucks of paid cloud services, and which are very accurate, right? I mean, you don't have to keep on using all the pre-trained models out there and apply your Python code on top of that. So yeah, if you want to use out of the box service, of course, Google and AWS and Azure, it is paid. But I mean, if you look at the charges, they are minuscule, right? I mean, it doesn't really, if you want to do a POC or your some sort of your own learning, I would say that it is worth the investment. It's not much. Okay. If the content language is different, so again from Madhu, if the content language is different than English, how this service will help in classifying the language basis headers which are in English, which can be seen, no problem, right? So as I said, there are the cognitive search itself gives you also the option for detecting the language. Okay, so if your language is Dutch, no problem. So if you have a language detection service, not service, language detection feature ticked there in your Azure Cognitive service, it will enable you to detect the content. So let's say it is probably French, and then you can also give a translation. So I also want a translated text translated into the destination language. So your source is French. I will choose that I also want language detection and then language translation. So from French to English, and I'm going to show the English translated text only in the search result. Possible. This is done by using your detection and translation services. Okay. So in current times, do we already have some products that give out an enterprise knowledge graph, or it is mostly treated as a custom project? No, you have enterprise graph products, which is Neo4j, for example, the most popular graph database, right? What to insert into that graph depends on, the content which you're harvesting, content which you're ingesting, mining, right? But there are enterprise ready products. If you want to have knowledge graph, for example, health domain, okay, so I'm going to probably put a link into the chat window for you to explore more. So I'm going to another website here. Okay, so let us look at Azure websites. Azure COVID, yeah, here Azure COVID demo. Okay, and let me search for ibuprofen. Okay, and graph relationships. Okay, so for a medical domain information site like this, it will have all the knowledge graph entities and relationships predefined. Okay, so this sort of thing you can get out of the box as a graph, right? So they have, I don't know, what the graph database they have used, either it is Cosmos DB with Gremlin API, or it is Neo4j. But nevertheless, for predefined domains like these health domains, you might get a enterprise ready graph already. But otherwise, otherwise you might be able to use some of the content databases, graph databases like Neo4j. Okay. Yeah. So as I said, right, enterprise databases you can note down for Neo4j, or then you can search these health related predefined ML models on which you have predefined entities and relationships and data sets from which you will be able to get this sort of a graph information. I see from Vinod, do we need to tag manually all the time, or there is some automation involved? Yeah, see, when we want to train on custom entities, right, it goes without saying that you have to tag the data. That, after, probably after a lot of times your model is trained, then you might be able to do some sort of automated prediction. So if I see a file, my algorithm is smart enough to automatically build a ontology. Okay. But otherwise, yes, if you want your algorithm to be able to recognize custom entities, you have to tag. But then the data tagging is probably, if I show you the language studio, right, you have to tag only 15 documents. So if I have a laundry list of 1,000 documents, I don't have to tag all the 1,000 once. I need to tag probably 15 or 20, enough for the machine learning algorithm to get a sense of the, training data, and then it will be able to do the predictions on the rest of the files on its own. But it goes without saying for all the ML algorithms, right, be it image recognition, object detection, text analysis, if you want to have some custom detection to be done, you have to tag. There has to be image labeling, there has to be data labeling, data tagging. There's no way out of that, right? Which is why you have domain experts, you have human in loop mechanisms to refurbish your search results. So yeah, absolutely. So from Somendupal notebook link, yeah, I will share it later on because I need to remove certain, confidential references and organization references from that. Monali Roy, I see what is NLP based search engine optimization work on behalf of enterprise software development. I don't really understand the question. I'll try to attempt to answer it, right? So, okay, so when you say that NLP based search engine optimization, all of the things which you are doing with the enterprise things like, okay, so software development for enterprise. All right, I can show you one thing, but I don't think it is going to work. You can look at Visual Studio GitHub Copilot. Okay, so what GitHub Copilot does is, as soon as you start writing your code, it will give you the next sentence. Like when you are writing your Gmail or your messages, right? You are on Teams, chat message on Teams, you are prompted auto replies, auto completes, right? Same way, when you are writing code, your GitHub autopilot, based on certain syntaxes and the way you are structuring your code, it is able to generate code snippets based on text comments. And it is also able to, like, say, probably, when I'm writing code and I have assignments, right? Like probably O dot employee name equals to XYZ, O dot salary equals to so and so, and then O dot, it will automatically complete that entire object population. So your IntelliSense, your Copilot, these are some of the enterprise software development mechanisms enabled by NLP search, NLP engines. Okay. How to create a Neo4j graph. Okay, so Neo4j is a product, right? So if you go on the website of Neo4j, you will be able to see that they have their own language called as Cypher. So using Cypher language, you can define nodes, which are the central, these are the nodes here, the circles which you see, and you will be able to define the relationships, edges, vertices, and you will be able to query that with the Cypher language. So just go to Google, check out Neo4j, and it is very easy to get started. Right, so there are free versions and there are paid enterprise licensed versions. So you can very well start with the free version. Piyush Mathur, anything that is in progress towards standardizing the tags, say in a domain? Yes, absolutely. Absolutely. So for example, I can give you very nice financial base example, right? So lot of the other domains, right? Your normal generic domain, your food domain, your health domain, they have a lot of standardized text. Okay, a standardized mechanism to do sentiment analysis, to do, keyword key phrases extraction. But financial domain is very tricky. Okay, so in financial domain, you will probably see that if I'm trying to do financial analysis based on the sentence alone, it can be very misleading. Let's say, for example, I have a sentence, something like, the US dollar skyrocketed as compared to the Indian rupee. Okay, so which means the Indian rupee was probably, let's say, one US dollar was 80 Indian rupees, and now it's skyrocketed to probably 180 Indian rupees. So which means it skyrocketed. So as a person who is monitoring this news as a part of India, it was actually a bad sentiment. It's a negative sentiment. But normally what happens is sentiment analysis is based on certain keywords like, for example, increased, skyrocketed, and, or the losses increased. So actually it's a bad thing in a finance domain, right? Or something that this loss ratio tripled. So only based on these things like ratio tripled and, losses increased, only based on increase, if you try to do the sentiment analysis, you will fail in a financial domain. So which is, you have certain, standardized models to be used. So let's say FinBERT. Okay, FinBERT in that case, for standardizing your tags in a financial domain and how to do the sentiment analysis in a financial domain. You have different ontologies predefined for certain domains, like ISO standards are there, ISO standards. So for an oil and natural gas domain, you will have certain set of ontology predefined for its pipes and, relationships between different equipments and nozzles, and how they are to be organized, the engineering diagrams and all of that. So there are ISO standards 14224, if I'm not wrong, which has a set of the standardized tags to be used in case of certain domain. So yes, obviously health domain has its own, finance domain has its own, utilities energy domain has its own. So there are a lot of predefined ontologies, taxonomies, if you really want to, go that direction. So currently we are working for a knowledge search, enterprise knowledge based search for an oil and gas. And this is where, we are coming across these kind of standardizing taxonomy, standardizing ontology. For tabular or time series data, how to implement semantic search? what is your definition of semantic search, Somendu? So semantic search normally comes in for unstructured data. For tabular data, okay, or time series data, it is more or less a structured data, right? Why would you want to implement a semantic search for that? Semantic search is mostly in a text context, okay? So it is mostly for unstructured data. I will not limit it to unstructured data, but mostly for unstructured data. For a tabular data, I might have a graph search, of course. I might have, what you can say, relationship search within a graph search, but not semantic search. Definitely not semantic search. Semantic search, which is your question answer sort of a setting, can be implemented only in a full text search sort of a scenario, right? So only in your search engines like your cognitive search or elastic search. So if you want to implement some sort of what you can say, similarity between different nodes, how similar two nodes are to each other, you can still do that in a graph setting, a graph database setting. All right. So I don't see any more questions here. If at all, you can always reach out to me on my Twitter handle or on my LinkedIn, and you can always drop me questions there. Glad to answer. And yeah.
I think no more questions. So
yeah, okay. Yeah, okay. So I just see last question, tabular data of product description and finding. Yeah, which is correct, right? So product description, you can index the product description into cognitive search. The tabular data itself will be indexed into your graph database. Like, okay, so probably your nodes will be there in the graph database and the description will be there into your cognitive search. And then you can still do the exact same thing for recommending, similar products. So you need to have a link between your cognitive search and your graph database, and you will be able to do this recommending similar products and your semantic search, no problem. All right, okay.
I think all the questions are over. It's the time for wrap up, Priyanka.
Yeah, yes, absolutely.
Okay, then thanks a lot, Priyanka. On behalf of Analytic Vidhya, I would like to thank you for your time and for delivering such a wonderful session.
No problem.
Okay, and I'm sure our audience found it very insightful, and hopefully we can conduct more such sessions with you.
Absolutely. Anytime.
One more request to the attendees, please fill the feedback form, as it will be helpful to conduct more such sessions.